This video lecture is for third semester BSc Physics of Mysore University. Dear students, in this session, I will discuss about the derivation of expression for current when AC is applied to CR circuit, calculation of impedance of CR circuit, and discussion of frequency response of CR circuit. Let us recap what we have learned in the previous class. We have learnt about the construction of an AC circuit consisting resistance and inductance, which is a LR circuit. We have also learnt about the expression for current when AC is applied to LR circuit and impedance calculation and its variation with frequency. Prerequisites for this session are knowledge about response of AC circuit with capacitance and resistance, knowledge about impedance in an AC circuit, knowledge about variation of current with the frequency of applied voltage in the circuit. Here we have a circuit consisting of a resistance in series with a capacitor. A sinusoidal voltage is applied to the CR circuit. The applied voltage to the CR circuit is given by V is equal to V0 into e to the power j omega t. For this applied voltage, let I be the instantaneous current flowing through the circuit. Let the potential difference across R given by VR is equal to R into I. Potential difference across C, that is across the capacitor, is VC is equal to 1 by j omega C into I. According to Kirchhoff's voltage law, for this loop, the applied voltage V is equal to the sum of the voltage across the resistor plus the voltage across the capacitor. That can be written as V0 into e to the power j omega t, that is equal to Ri plus 1 by j omega c into I. For simplifying this equation, let us substitute R is equal to Z cos phi and 1 by omega c is equal to Z sin phi, where Z is the impedance of the circuit and phi is the phase angle between applied voltage and the current in the circuit. Then we get the equation in terms of the current I is equal to V0 into e to the power j omega t divided by R minus j by omega c. That is equal to V0 into e to the power j omega t divided by Z cos phi minus j into Z sin phi. After simplification, we get the current I is equal to I0 into e to the power j omega t plus phi, where I0 is the peak value of the current in the circuit, that is given by V0 by Z. That means when the complex voltage V is equal to V0 into e to the power j omega t is applied to a circuit containing a resistor and capacitor in series, the current flowing through the circuit is given by I is equal to I0 into e to the power j omega t plus phi. From this expression, we come to know that in an CR circuit, the current leads the voltage. Now, we shall move on to the calculation of impedance of CR circuit. As we defined the impedance in our earlier sessions, impedance is the total opposition to the current flowing in an AC circuit that contains both resistance and reactance. Here the reactance is the capacitive reactance offered by the capacitor in the CR circuit. This impedance is calculated as Z is equal to square root of R square plus 1 by omega C whole square. The impedance varies with frequency. Now the frequency response of CR circuit. The frequency response of a CR circuit is the variation in its behavior with change in signal frequency. RC circuit behaves like a low-pass filter. A low-pass filter is that which passes low frequencies and blocks high frequencies. Hence, we can sum up, in a CR circuit, the resistance is independent of frequency. Inductive reactance is inversely proportional to the frequency. Total impedance Z increases with frequency.